Hi guys, in this episode of Shri series, we're going to be talking about how to calculate the number of protons, electrons and neutrons in an isotope. Alright, so I'm going to give you one example to illustrate how we can calculate the three subatomic particles found in an atom. Alright, before I go any further, I just thought I explain a little bit into what an isotope is and what are the requirements to calculate that. All right, so if we were to define an isotope, all right, there are two things you need to understand. There's one number that is the same and another number that is different. All right, so always remember when you're looking at an isotope, isotopes will have the same atomic number, but they will have different mass numbers, right? So in a nutshell, if you were to define what an isotope is, these are atoms that have the same atomic numbers but different mass numbers, all right? Now, I haven't explained this in this video, but when we define an atomic number, all right, if I just write it here, your atomic number is the number of protons present, all right? And your mass number is number of protons plus neutrons. All right, so in a nutshell, your mass number is larger than your atomic number because your mass number contains protons and neutrons, whereas your atomic number contains only the number of protons. All right, so it's very important to understand what an atomic number and mass number is, and that's what you see in a periodic table. All right, now I've explained what an isotope is. Let me just show you very briefly how we can represent mass and atomic numbers. All right, so if you look at a periodic table and you see an element, suppose I'm just making things up, you've got an element E. All right, what will happen is your mass number will be the bigger number. Now sometimes you will see different periodic tables put the mass number above and other periodic tables put the mass number below, but always remember the symbol for your mass number is A and the symbol for atomic number is Z. All right, so always remember your Z is your mass number, which is the number of protons and neutrons as seen here. So I'll just put an asterisk here just to illustrate what that is. All right, and your atomic number, all right, is this one here, which is the number of protons. Now you must remember this very carefully, and that is when an atom is uncharged. All right, so what do I mean by uncharged? All right, an uncharged atom is a neutral atom that has neither lost nor gained electrons. We will talk about what charged ions are in the next couple of videos, but for this level, when you're looking at an uncharged atom, it is a neutral atom, and what happens in a neutral atom is the number of protons will be equal to the number of electrons. All right, when we talk about charged atoms, that's slightly different because you're looking at atoms that have gained electrons and lost electrons. So in those situations, the number of electrons will be different from the number of protons. So for this level, let's look at an uncharged atom. All right, so with that in mind, we've explained what an isotope is, we've explained what atomic number, mass number is. Let's look at a simple example on how to calculate the number of protons, electrons and neutrons, all right, of an isotope. All right, now one commonly used isotope that is used in examples as well as in assessments is the carbon isotope. Now if you look at carbon on the periodic table, its symbol is C, and that's 12 and 6. All right, so we know very well the bigger number is your atomic number, your smaller number is your mass number. All right, now you will see that in as much as the carbon that you see on the periodic table is this one here, they are isotopes of carbon. There's carbon 13 and carbon 14. So I'm going to put carbon 13 here and I'm going to put carbon 14 here, and what you will see here is they've got 6 and 6. Okay, so you will see that carbon will have three isotopes, namely carbon 12, carbon 13 and carbon 14. However, the carbon 12 is the isotope that has a higher percentage abundance of existence, and hence you will see that carbon isotope present in your periodic table. All right, so with that in mind, let's calculate the number of protons, electrons and neutrons. All right, so I'll just construct a very simple table here. All right, another one there. Suppose we'll call that proton. Number of protons, number of electrons, and number of neutrons. I normally refer to this as PEN, which means protons, electrons, and neutrons. All right. So when I'm explaining to students, I'll be like, all right, guys, we're going to be talking about PEN of these atoms. All right. So P for protons, E for electrons, N for neutrons. Pretty fairly self-explanatory. All right. So let's look at the number of protons in carbon 12, carbon 13, and carbon 14. We know very well that your atomic number is the number of protons. So that's going to be 6. If you look at carbon 13, that's also 6, and that's 6 there. If you look at the number of electrons, I did mention in an uncharged or neutral atom, the number of protons is equal to your number of electrons. So your protons is 6, so therefore your electrons will become 6. However, if you want to find out the number of neutrons, you need to subtract the mass number and your atomic number. So 12 minus 6 becomes 6 here, 13 minus 6 becomes 7 here, and 14 minus 6 becomes 8 here. All right, and that explains to you very well that the number of protons, which in this case is 6, or your atomic number, is the same. And if you look at the number of neutrons, all right, which is really the contributing factor to your mass number, because mass number is the number of protons and number of neutrons, you will see that the neutrons change. And that also explains your mass number is different. So this explains the definition of an isotope, that these are elements that have the same atomic number but different mass number. And if you look at an example using the number of protons, electrons, and neutrons of a carbon 12 or carbon isotope as stated here, you will see that the protons will be the same, electrons will be the same, but your neutrons will be different. All right, so I just thought I'd illustrate this video to talk about how to calculate the number of protons, electrons, and neutrons in a simple isotope by giving an example. All right, thanks for listening, guys. Bye now.